Welcome to another enterprise session from the University of Bristol. My name is Professor Michelle Barbour, and today I am enormously fortunate to be talking to Professor Marc Holderied, who is a member of our School of Biological Sciences. Marc, thank you so much. I have some idea of how busy you are, and I'm sure it's 10 times, 100 times more than I even know, so I'm really grateful to you for spending time with me today.
Michelle, there's nothing that would keep me from here. Thank you so much for having me.
Wonderful. This is going to be a great discussion. Okay, Marc, so maybe let's kind of rewind in time. Let's go back. So you've been at Bristol for a number of years now. You are a professor in our School of Biological Sciences. But what happened before that? What led you to Bristol and what led you to your area of research?
I wanted to be a scientist before I could pronounce it. So actually, it came naturally. I was asked to be a postdoc here by one of my still colleagues about to retire, Gareth Jones, in the same department. Did that postdoc, returned to a bit of a tour of the world, and then I was headhunted. I got this phone call. We've got these positions going. Don't you want to apply? Did, and got here and never regretted it for a day.
Fantastic. Brilliant. So you've been at Bristol, you'd gone away, and then that magnet that is Bristol just brought you back again.
Absolutely. Yeah. Repeat offender, I've been called.
Brilliant. I like it. And before we get into your enterprise work, which is obviously the focus of our discussion today, but what's the day job in biological sciences? What do you do? Do you teach, you research and so on?
So normal professorial schedule, I'd say, maybe a bit heavy on the commercialization side because of the stuff we'll be talking about a bit later. But I teach, I've got a full teaching load. I do research. I've got a group of postgrads and postdocs that I manage. And it's all about acoustics for me. So my research is really into what amazing things we can do with sounds. And that goes from conservation acoustics. I work a lot with Bristol Zoo. I'm the academic from this university with most links. Over the years, we had 20 postgrad students all over the world. To robotics, I do sonar-guided robotics a bit. And then our bio-inspired research into ultrasound and then trying to turn that into something that helps us. So looking for things where nature has found amazing solutions that then help us live better lives.
Fantastic. So before we get into that, tell me a little bit about your work with Bristol Zoo. What sorts of projects have you worked on with them over the years?
So Bristol Zoo is just a fantastic resource that we have at our doorstep. They've got a very dedicated conservation team, so everybody visiting does a small donation. My students are partly funded by this. And over the, I think, 15 years, we've had so many PhD and master students that we send over to many places, the vast majority going to Madagascar. And working on different projects, a lot of it at lemurs. We've just had one student coming back working on the amphibians. He discovered a new species of frog, which is pretty amazing. And
how many PhD students can say that? I mean, that's incredible.
I think it's even a master student only.
Oh, my goodness.
It's even better. So now we need to sort of get that all published and written up and ID'd and named. But what an exciting time for that student. And we're about to send another student out to work on bats there. And 12 years ago, we recorded a bat call, which we know doesn't belong to any known species. So again, we've got a real chance to catch that and describe it as a new species to science. So we've got a team aligned, international collaboration to get that. And at the core of this is another master students that we have with Bristol Zoo going to Madagascar.
What extraordinary experiences for your students, though, because that's real discovery science, isn't it? And I like the idea. I sort of think of identifying creatures, organisms by what they look like, how they behave, their habits and so on. But actually sound has led you to recognise that this is something that needs to be looked at and characterised, but it was sound that was the tip-off, that was the kind of first clue, right?
Absolutely. So allow me to digress. So there's Gareth Jones that I've mentioned before. He discovered a new species of bat in the UK. And these are cryptic species. Before it was considered one, now it's two. And the only way you can tell them apart is by their echolocation calls. So one is now called the common pipistrelle, the other is called the soprano pipistrelle, because it has a higher voice.
Fantastic. So I can see straight away how you have become so deeply fascinated by acoustics, by the world of sound as it pertains to animals. I mean, it's the way you tell it. How could you not be fascinated by that? So tell me a little bit about the work that led up to you going on your enterprise journey, the research that's the bedrock on which that's founded.
Okay, so for that we have to go back quite a few years. I think the not the eureka moment, but the first inspiration came when I was a PhD student, pretty much exactly 30 years ago. And I was invited by my then supervisor to Costa Rica to do some research. We were taking echo measurements of flowers, and I saw this super fluffy moth sitting on a wall. So I captured it and I measured its wing echo intact, and then I shaved the wing, trying to find out whether this fluff on their wings had any effect on the echo strength.
I love this. I'm just picturing Daily Mail headline: student shaves moth. Like, no, there's a really important scientific purpose to do this, and it's led you in lots of different interesting directions, I know, but I can never resist thinking of the headline. Yes. So sorry, you captured this incredible moth and you measured its sort of sound properties with and without the fluff, as it were, on its way.
Exactly. And at that time, there was some indication that something might be going on, but our technique and my control over this wasn't quite there. So basically, on and off, I've worked on this project ever since. And at the core of this was developing a toy, a research tool, which is one of a kind globally. It's called an acoustic tomograph. So it's a machine, I can put any organism in it, and then I send ultrasound from many different directions, and I can measure and build an echo image of the object, very much like a bat does. But now we've got these as 3D images. So it's pretty stunning to see an image emerge from sound waves. And that allowed us to then finally go and revisit that original idea. So I hired somebody who is the world expert in shaving moths now to do this in a systematic way. And this is when we made our discovery that something truly remarkable is going on the wings of these moths.
So park that cliffhanger just for a moment. Tell me this: you were a PhD student in Costa Rica with your then supervisor. Was the observation you made of the moth and the very initial experiment you made, was that part of your PhD? Was that the substance of what you were supposed to be doing as a PhD student? Or was this sort of a peripheral interest?
I think that this was more like a total serendipity. So my PhD project, was actually on tracking flying bats.
Okay.
So very different use. And I was there only to help them measure echoes of flowers, which I've worked on, published on, but it was not topic of my PhD. And then finding that moth, it happened. You've got a couple of hours free on a day, and that was the side project I chose to work on.
Side project, side quest, I would say. Quest because after 30 years, you said it, so I'll use it now. This is you've never been able to quite let go of it. This observation you made, you needed to scratch that itch. You needed to understand what was going on.
Absolutely,
right?
Yeah.
Okay, so I've kept the listener waiting long enough. So what was it that was happening on the surface of these moths' bodies?
So you have to think about a moth as being under constant threat from many different predators, and a night-flying insect. For those, bats, echolocating bats, of course, are the main biological threat. Now, moths don't want to be caught by a bat, so evolution has equipped them with a whole range of different defenses. And one that we discovered now, let's say 7 years ago, is an acoustic invisibility cloak. So a bat depends on the echoes that are reflected off the insect prey to find the prey and then catch it. Now, an acoustic invisibility cloak works by receiving the sound that the bat sends there, the ultrasonic echolocation calls, but not reflecting them back, but rather absorbing them, hence acoustically invisible. Now, this is something that we do in our offices when we have noise control sound absorbers. But for the moth, the challenge is that these sound absorbers need still to allow the moth to fly.
Exactly. You think about the sort of things you'd have in an office environment, or I'm thinking of the ceiling of a big concert venue where you don't want echoes, but they're not exactly applicable to moth scale, right? These things need to be able to move and, as you say, fly.
Absolutely. And the big challenge is the thickness of your absorber. So if you want to absorb a sound, you have to have a certain thickness to make the absorber work. And what we found is that the normal absorber, and that's in all the textbooks, needs to be about 10% of the wavelength of the sound it's designed to absorb. That means there is a lowest frequency absorber can absorb. If the frequency gets lower, the wavelength gets longer, and that absorber becomes inefficient.
So if this were applicable to the moth, if evolution hadn't stepped in, which I'm assuming it has, what would the thickness of the sound absorbing coating on the moth need to be? If a moth is, I don't know, a few centimeters across, how thick would that need to be?
So to give you an idea, so if you think of a moth, you're probably thinking about something very furry, definitely more furry than a butterfly would be.
Sure.
And that fur on the body is also a sound absorber. That's a normal traditional sound absorber. It's about 1.5 millimeters thick, and that's about as thin as it can get for the frequencies, for the wavelengths that it needs to work.
For it still work, yeah.
So that's cool, but that's 1.5 millimeter on all surfaces. So for a wing, that would mean a wing that has a total of 3 millimeter thick scales up to the wingtip.
That's a fat, heavy wing.
Fat, heavy wing, absolutely aerodynamically impossible to work. So evolution had to find a solution for that problem and had to design something that's much thinner. And evolution, being the fantastic inventor that it is, of course, it found a way to make it thinner, and it achieved something that's about 10 times better than what we could do before. And it's, to get a bit technical, it has evolved the only known acoustic metamaterial that we know exists in nature. Now, a metamaterial is something very exotic. Metamaterials are very powerful. They can do the most amazing things. They help us in our smartphones. They help us in medical imaging. They have all sorts of uses. And they work by putting many different components together in a special arrangement. And by interacting and by working together, they create something that is more than the sum of their contribution. We are talking about emergent properties, very exotic emergent properties often. And in this case, that lent itself to design very powerful but ultra-thin sound absorbers. As I said, 10 times thinner than anything that current technology has on offer.
So, if I've understood you correctly, the differentiation between just a material, the stuff that we make stuff out of, and a metamaterial is, I think you're saying it's a material that derives its properties not just from what it's made out of, but its physical structure, the way it is put together, the shape, the form. Is that fair?
Absolutely, yeah. So it's hard to come up with an easy image to show what's going on, but structural color often also found on the wings of butterflies. So when you've got these shiny iridescent wings which change color as you move them, that's a typical metamaterial.
Okay.
So there's structures in there that are at the range of the wavelength, and they create these interference colors. That is something the individual reflector wouldn't do this, but put them in the right spatial arrangement, you get these emergent properties. And in our example, it's just super powerful absorption.
Brilliant. So what an amazing discovery, what an amazing project to give to your colleague or your PhD student who was able to investigate this really thoroughly, the world expert in moth shaving, which I just want to see that line on someone's CV. That's amazing. So I can see how you could very easily have written some really great research papers, probably found some sort of follow-on investigations to do with students to explore this in maybe related species and so on. And chances are you did that. But you've also decided to take it in a sort of entrepreneurial direction. So talk me through that. What inspired you to do that? Were you looking for an entrepreneurial sort of project, or was this, how did this emerge? Talking of emergent properties.
So thinking about what drives me as a researcher, I'm a curiosity-driven researcher. I like to understand how things work. But at the same time, my biggest motivator is to do something with these discoveries, make sure that we are not missing out on not taking all the amazing lessons that nature has on offer and turning them to our advantage. That means as far as biologists go, I'm very much an engineering-minded biologist, always having this drive to design bio-inspired solutions that help us. So that's my dream, that we show how nature helps us and thereby increase the appreciation of humankind, of what nature is and why we should care about it much more than we currently do.
Fantastic. And when evolution has spent millennia, or more than millennia, millions of years designing and discovering structures and perfecting and honing them, why shouldn't we actually really understand that and then see where it's applicable to other of our needs? Now, we don't need acoustic invisibility cloaks as such, or at least most of us don't. But there are lots of applications for the sound absorbing materials that you've sort of gone on to discover or develop, I should say. So talk us through this. We all know there are lots of hazards in the world. If you ask somebody to name the top 5, sound might not be in them. So what is it that what are the problems you're trying to solve with your materials? Okay,
so now we know that the moths do this, that they're 10 times more powerful sound absorbers. The first step was we had to translate it to wavelengths that we care about, stuff that we can hear.
Sure.
We've done that. And now we can absorb sound much better. One of the products we were floating out there is something called acoustic wallpaper, something
Okay.
that's so thin that you would be prepared to put it in your living room and it would help you with living a quieter and healthier life. So, but what's the actual use for this? So when we talk to people about this in many different sectors, everybody who has to control noise, be it engine noise or noise in an office or the noise in a music theater, you mentioned concert hall, same thing. Everybody is looking for thinner and lighter, better solutions because it reduces the weight. Think about an airplane, keeping a less noisy airplane comes with a fuel cost. So if you can have a lighter sound absorber, it's becoming ecologically less polluting just by replacing it with a lighter sound absorber, or you can invest the same weight and make it quieter. I always find planes way too noisy.
And is this in the plane or from the ground listening to the plane going ahead? Where is the application in planes?
So the stuff that I'm talking about now was in the cabin, so trying to keep the cabin quieter.
Yeah.
But the same applies to maintaining the noise that the engines produce and either directing them in a direction that we don't want them or absorbing them in the hull of the plane so there's less of a nuisance. There's a lot of research, a lot of money going into this. So to cut this long story short, everybody working with sound would love to have a better solution, a thinner solution. And to put it into something that we might relate to, sound, man-made noise pollution, is a substantial health risk. Actually, it's the second biggest environmental health risk we are exposed to. We all are exposed to sound much higher than we would have been in pre-industrial age. Well over the half of us live now in urban environments. That number is going to increase to over 2/3 of us by 2050. And in these urban environments, you're exposed to harmful level of noise continuously or at certain intervals, and they always have a negative health impact. That health impact can be measured. It has an economic impact and it also has a personal impact. So on a societal level, if you're thinking about how much it costs the UK to deal with the damage done by noise, and that's on many different levels. That's hearing loss, but that's only one aspect. It's stress-related problems, cardiovascular, pregnancy. All of these contribute stress levels that lead to an ability to work. That is measured at £25 billion every year, just noise-related costs, societal cost. Another example, traffic noise, just road noise, costs society more than all the road accidents taken together.
I find that phenomenal. Do you feel that is widely known about? I feel like we don't see this in headlines.
So planners will know this. So if you've got road planners, they know what they should do to keep the motorway noise out of urban areas. So on the motorways, we increasingly see these sound-absorbing walls being set up alongside the motorway where there's urban areas. But in the city itself, where there's a lot of road noise, of course, we can't do this. We don't have the space to put up these sound panels. And we are lacking solutions that would work. So it would be great if we could just soundproof all the windows. They get very heavy and very expensive, such that mainly big motorway-sided hotels can afford them. But wouldn't it be great if everybody could afford a sound absorber that keeps the noise out? And that is one of the promises that we are trying to deliver on.
I just think it's absolutely startling, the figures you've given of the damage that noise does. And I wonder, I suppose, you compare it to the sort of road traffic accidents, it's clear the damage they do. It's just very visible, it's very obvious. But I wonder if it's just that sort of chronic and almost invisible impact of the noise that happens over a long period of time, that people just don't recognise it for the detrimental effect on our lives that it really is.
I think we have a bit of catching up to do. So there is an underappreciation of just how damaging the day-to-day noises that we are exposing ourselves to.
Fantastic. So you have identified, and not you alone, many people have identified the detrimental effects that noise has within cities and other environments. And you've got these moths with these incredible metamaterials on their wings that evolution has provided to them and now to us. So join the two. How did you go about taking inspiration from the moth? Because I'm guessing, this isn't sort of 101 Dalmatians where you're just going to breed all the moths and then stitch the wings together. So there's some kind of like conversion of what do we need to keep of this material and what can be changed to be something that we can actually produce at scale.
Absolutely. So the first thing you need to do is understand the fundamental principle. And then, as with everything in biology, nothing is there with only one purpose. Everything in evolution has multiple purposes. So the next step was trying to drop features, trying to work out Occam's razor. What's the absolute bare essential?
The minimum viable product from an environmental point, an evolutionary point of view.
Yeah, exactly. And that process took us some time and some funding. So in total, we were talking about 7 years of fundamental research. And by the end of this, we had the fundamental principle cracked. We knew how to replicate it. And that allowed us to scale it to greater dimensions to fit the greater wavelength that we as humans care about.
Fantastic. So there's, even once you had this idea of the application, the commercial possibilities of the material, there was still 7 years of academic research to do. And I think that requires real staying power. I think sometimes people think commercialization is quicker than research. Just quickly, just get something out there and start selling it to people. And this is a really good highlight of that's often, almost always, I would say, not true. But you had this end in mind. You had this addressing the problems of noise in mind. So having cracked that, you then got to the point where not the research was done, the research is never done, but the key parts of the research were pinned down. Research funding is for research. So where does one go as an academic when what one wants to do is a little bit beyond research and into what sometimes we call it technology readiness levels, sometimes we call it other things, but how do you get the support? Because the research funding dries up at a point and you need some way to move it to the next stage. So what was that next stage?
Okay, so that is clearly the critical transition moment. You could call it a career pivot moment. So for me, this came, as you said, when research funding dried up. I had big plans to get European EIC funding, which was at the interface to commercialization. And I still don't know why, but we didn't get it. So that means I had a team, I had a fantastic machinery running, and I had this desire to commercialize it. And while I wanted to keep it a balance between research and then let the commercialization aspect grow more steadily, that was the trigger moment to say, okay, let's just go full steam ahead with commercialization. And this is when I discovered that Bristol-based impact commercialization ecosystem is a fantastic research, a fantastic environment to be in. So within 3 months, I have managed to raise enough tech transfer, impact acceleration funding to continue my research for a further 2 years. And that comes from a wide range of different sources. So for starters, very important for myself was I was an enterprise fellow in 2023, one of the first ones, inaugural, and that helped me massively. Maybe we can talk about that a bit later. But I also got a lot of funding from something called the EPSRC Impact Accelerator Award. That's money that is given by the government via EPSRC to the universities to allocate to projects. And I'm incredibly grateful to the team who does this allocation because I got very substantial support over the last 2 years. I also reached out for other commercialization headed funding streams. There is one from the BBSRC called the Follow-on Fund, which we have and which we are employing people on right now. And right now, last week, we submitted another application for these sort of commercialization bridging grants called the UKRI Proof of Concept Call, a very new approach and a very new concept. Also, lots of other financial support, for example, from the BBI here at the University of Bristol. But last but not least, immense support from our own Division of Research, Enterprise and Innovation, DRE. They are a fantastic bunch. They have been super supportive, both in in-kind support by having their team members join us in our development journey, advise us. They've provided us with business advisors. They've helped us with the patenting costs. We've got a patent by now on this technology. And in general, I could not have done anything, or at least not at the speed that we have been doing it, without massive, massive impact for them. So if you're thinking about commercializing, talk to them as soon as you can. And the more you talk, the more you learn. And they're always happy to help and support.
That's wonderful to hear. And I too have been supported by the teams you mentioned, and I couldn't agree more. They have incredible skills, amazing people. I think I'm preaching to the converted here. You're taking a journey and doing it extremely successfully, but some of our colleagues would be less open to these sorts of experiences. I think I perceive a couple of main barriers, and I'd be really interested if you agree or if you think there are different barriers or whatever it might be. I think one is, as established academics, which I would describe you and I, to slightly different degrees, I think we trade on our expertise. We are experts. We stand up at conferences and we sort of talk about our research and so on and so forth. If we're taking a direction into commercialization, for most of us, we are completely clueless. We don't know what to do. Some of the language is unfamiliar. All the acronyms don't make any sense. You have to go back to, on 101, absolute basics of some of this terminology. And I think that requires a sort of courage and humility that is really uncomfortable when what your stock in trade is your expertise. So I think that need to be uninformed and be a babe when it comes to these skills, I think that's a barrier for some people. The other one I think is almost quite different, which is I perceive that sometimes there's a feeling that if somebody pops their head above the parapet and mentions to somebody from our commercialization or our impact teams, I've got this idea, I found this thing, I've developed this widget, whatever it might be, that you're standing on the edge of a precipice. And if you put a foot over, that's it, you're gone. You're going down a slalom ride. There's nothing you can do. It's out of your control. It's out of your hands. And who knows what terrible uses your innovation might be put to, So there's the sort of irreversibility of that step, or the fact that step exposes you as being an engineer and being uninformed. Those are what I perceive to be barriers. I mean, would you agree or?
So, absolutely. So I think you described the situation you find yourself in when you're first seriously considering this pretty well. So you know nothing, everything is new, and everything is, I'd say, even contrary to what you've been taught and what your successful strategies were so far. Let me elaborate. So for us as academics, the biggest motto is publish or perish. If we've got the most amazing story, but we can't get it out there, that's nothing. It counts for nothing. We haven't done our job. Yeah. If you want to commercialize something, the prerogative is the opposite. Keep your mouth shut. Don't talk about your amazing invention up to the moment when you've got the IP protected. And I learned that the hard way. So the first time I reached out to our brilliant IP team, I told them the story. They were very excited. I said, and here are all the papers to support this. At which point they turned away and told me, well, go out there, create new IP, and then we can talk again. So 3 years later, I return, and this is what this all is being based on. So if you're serious about this, with everything you do, that's even an interview, that's a talk, a poster, make sure that you're not giving away something that then somebody could use as existing previous open knowledge that you then can't patent protect anymore. So that's the first biggest step that was a hindrance. First, a training hindrance. I didn't know I wasn't supposed to do this. I was told to do something different before. And it's also an emotional hindrance. You're going against your instinct. That's you're not supposed to be not talk about what you do. So that's one. The other, the precipice. Yes, there is this one, but as soon as you take the first step, that goes away. Yeah. Because everything depends on your decisions. So it's not like this downfall, like on a slide where everything happens by itself. You have to make decisions. You are in full control of this. And by the way, if you're publishing some things, you have no control over who might be using it for whatever purpose. So actually commercializing it yourself, you're in much more control if you're concerned about abuse, for lack of a better word, of the invention that you've made. So to me, the step in was triggered by the lack of money. So I have to admit that. And I had this moment when I said, let's just let go, let this live its own life. It was great while it lasted. But I knew that I would feel regret for the rest of my life. I had this lump of this raw diamond in my hand, and not doing something for the fear of entering the world of commercialization just felt so wrong. And overcoming that took a bit of courage and convincing. But for the last 2.5 years, I've had an amazing learning curve, met so many amazing people. There's a completely different world out there of exciting people that can inspire you. And I think personally, building these connections, meeting these people, and learning all these skills has been the most rewarding part of this. And going back to 2.5 years ago, I still think that I know very, very little of that world out there, and I've got a long way to go. But this is just what it takes to get a company off the ground. Some of might be faster. We have been at it for 2.5 years, but that is largely down to the fact that our invention is what we might call a platform invention, where there's so many different uses. And that means before you take a step or take some big decisions, you want to make sure you covered all your bases. So the planning and the setting up takes longer than if you've got a product rather than a platform. And that is what I had to learn. And yeah, I've got a lot of motivation and drive to do this and a fantastic team to do it with.
It's wonderful to hear. It really is. And there's lots of things I want to explore. One is, as I've understood it, you are working towards your spin-out company, and we'll certainly come on to that in a moment. But you're still a researcher. You still have a research group. You still have students, postdoctoral researchers, and so on. But their environment has changed because you have learned and changed your environment. So do you see that it has an impact, positive, negative, or otherwise, on the people who sort of look up to you as their supervisor, their boss, their PI? Are they seeing things they wouldn't have seen otherwise? What emotions do they elicit? Are they fascinated, horrified, perplexed?
Yeah, absolutely. I think the way I run my research team and inject my experiences into our wider postgrad community have definitely changed. So I'm invited to talk about commercialization on a regular basis, and I enjoy doing this. And you can see that in the academic audience, there's a divide. You can see some that are proper curiosity-driven scientists who are there for the fundamental science, and that's it. They don't want to take that extra step. And then you quickly you can pick out the ones that actually have this commercial spark, the ones that pick up on this and then want to do what I want to do. So I have this dream of giving something back, making a career beyond creating knowledge. It's like creating products, creating something bigger and give something back. And I find that interesting, and that has changed, trying to find the people that are good for this and trying to inspire them. The students that I send out all over the world, I think it's a long shot for them to look into commercialization, but I've got some projects where we develop remote sensing technologies, where we connect a microphone to a solar panel up in the Lake District and just listen in to what's going on there on the soundscape. And one fantastic project we have at the moment is on red and grey squirrel interactions, where the greys were just moving into a forest that we were observing. And with our remote listening, we then saw that the greys were going in, and then they were being pushed back by the rats again.
Wow.
And when we looked closer, we saw that something remarkable happened. From further north, from Scottish populations, pine martens had moved into that forest. And amazingly, the pine martens feed not exclusively, but mainly catch grey squirrels, and the red squirrels are unaffected. So basically, by teaming up with the large pine marten as a predator, now the reds have a fighting chance. And I do hope that coming from the north, that wave of pushback will roll over us.
I love it. There's a Pixar film in there, the pine martens as the red squirrels' bodyguards. Yeah, absolutely. That's incredible to hear. So, okay, so many things to explore. You mentioned, alongside the fantastic support you've had from our teams in our Research Enterprise Innovation division and the various funding pots you mentioned, you were, as you said, one of my inaugural Enterprise Fellows. Tell me a little bit about what that provided for you, because you had other means of support. So did that add value? What did it do that was differentiated?
Okay, so the Enterprise Fellowship gave me a lot of things. So first of all, it gave me a title, and a proud title to wear. I still wear it very proudly. It gave me some buyout money, so it gave me a bit of teaching relief, even though that was slightly delayed because of the short turnaround times. And it gave me some money to spend on this 12-month period. So that's the hard return that you got. But much more important is the community it created. So it wasn't just me. There was a cohort of Enterprise Fellows. We came together regularly. We quickly bonded. I've got very good friends out of that phase, out of that cohort. And there was this, wow, it's us. We're doing this now. That whole feeling of, starting in new directions for us, pioneering. Yeah. And laying some roots for future generations. And that whole experience was very rewarding in itself. And I I love attending events like the Festival of Enterprise. We had one yesterday. Very inspiring and inspired people there. So it's exactly the sort of community and ecosystem we want to provide. And it's great to be a part of it and to have maybe helped a little bit to shape it.
You certainly have, my goodness, absolutely. And I'm very grateful for that. And the way you describe it is wonderful. It's music to my ears because that's exactly the sort of thing I hoped it would do. Another thing that I was interested to see with the Enterprise Fellowship sort of program was I'm one person and we've got 9,000 staff. And as you rightly say, some researchers will never want to do that. And that's fine. I am not looking to convert everyone to this kind of pathway in their career. But there are those people out there that have that spark that just needs to be kindled, whether they know it or not. They have that spark. But what I find, and it's logical, it's obvious, I suppose, if you think about it, that I can't go and talk to all of these people. A, there's only one of me and 9,000 of them. But B, I don't always have the authenticity, the resonance. I know what I know, and I don't know much about a lot of disciplines within the university. So for me to say, hey, this is great, you should try it, it's really exciting, it's not going to resonate with everybody. But when somebody that you share an office with, or you teach alongside, or that you just see in the coffee queue in your department is doing something in an entrepreneurial direction, I always hoped it would almost have like a little bit of a ripple effect. Not that it would convert everybody to that direction, but that even those researchers who didn't want to do it would see the value, see the point of it, see that it's something that's valid for an academic to do. You can say no, but have you observed anything of that nature?
So what I observed over these past few years is I think there's a gradual change in attitude, maybe even culture, where people are aware that this is part of what an academic's life can be. It's optional, as you said, not everybody has to do it. But I see an increased awareness of this. So I've been invited to early career events where I talk to how my journey was and try to inspire them to actually take the step. That's something new that wasn't there before. And the numbers are growing for these events. So that clearly we are providing something that wasn't provided before. So obviously we can't do one-to-one talks and train everybody, but we can work towards a culture change. And that requires a bit of infrastructure, continuity, like this podcast. It's definitely a part of that culture change. And then some role models, some people that can serve as an inspirational journey or a commercially valuable journey to inspire others to follow in their footsteps. And if us as a cohort or cohorts of enterprise fellows can sort of serve in that role, that would be fantastic.
Brilliant. And well, yeah, I certainly hope you can. Okay, so back to your journey, back to your technology derived from moth wings and now scaled, and you're looking at all the many, many potential applications. So I hear there's a spin-out company sort of in the waiting to come out of the wings. Yep. So tell me about it. I think you have to announce the name. It's not my place. But tell me about your company and your hopes and plans for it.
Okay, excellent. So yes, of course, as being a university researcher, the route to commercialize your invention, your discovery, is through a spin-out company, university spin-out. And we've chosen a name. They're going to be called Attacus Acoustics. Attacus is the genus of moth. It's the largest moth in the world, and that's one of the species that we have discovered this invisibility cloak on.
Incredible.
It's also beautiful, and it features in our logo and everything.
You've given the moth the credit. You haven't sort of stolen the moth's thunder. I like it.
Absolutely. They are giving back. It's not us creating this from scratch. So Attacus Acoustic is the name. We've got a website, we've got emails, we've got an infrastructure there, we've got a team, we've got a patent.
Excellent.
We've got a university that is massively supportive. We haven't spun out for a number of reasons. This will happen in the first half of 2026.
Excellent.
And we are working, we've got a plan that we are implementing to do all the steps. So we are ready for this, because once you step out from under this fantastic umbrella that the university is providing, then you have to be able to fend for yourself, find the money, find the markets. So you want to do this step at the right moment in time.
Absolutely. And often not heeded warning. I think some people are in such a hurry to spin that they do it too soon, or sometimes delay out of a sense of, fear, trepidation and miss an opportunity. So that's something I really applaud. You mentioned team. So, clearly you are someone with many, many skills, and more skills than you had a few years ago because of all the journey you've gone through. But what How have you identified what you need in that team? I'm not sure it's immediately obvious to us as researchers. We know what skills we don't have. We don't know what skills we need. So how are you building that?
I think that is the most important question. I think to me personally, for building our team, building our company, that's the one that I'm spending most time on at the moment. I could summarize it as finding the C in academics. Of course, it's the second letter in the word, but that's not the point. The C being the C roles for the company. So the CEO, the CTO, they require a very specific skill set. And it's very hard to find that without a lot of exposure. So, and sometimes people with the best intentions start on that journey and at some point realize that it's not for them. And it's better to realize that and to be honest to yourself, even if it sets back the project, rather than set somebody up who doesn't enjoy it as well as he or she should, to take on that role. So at the moment, I'm on the hunt for a couple of Cs, and job adverts will go up within the next week to recruit some people who, if they want to, can transfer with that whole project from the university and then next year transfer over into the company.
That's really exciting. And you say, and I completely agree, that they need a specific skill set. Do you know what that skill set is? I mean, you say job ads are about to go live, so perhaps you do. But when I have my own spin out journey, and I don't think I could have written down half a dozen bullet points about what I needed my CEO, COO to do. I could now, but at the stage you're at, I think if I didn't know, I wasn't that clear on what it was I needed.
And I completely agree. So it's not like a tick list where you can do. The spark is something that sits in between. It's hard to put the finger on. That's exactly what makes you the perfect CEO. People that have been in the trade for a long time probably can by interviewing you and reading between the lines. We've had one panel discussion where we presented our work, where some of the experienced team said, well, this is good, but you are lacking in this and this. So I'm not going to go into any detail. And half a year later, that was almost prophetic. So they had identified the weak spot, and that was the breaking point at that moment, which was a hard time for the company. We have recovered. But yeah, you can't pick the people. You have to do the journey with them. And then if it works, perfect. If it doesn't, then you have to just look further.
Yeah, and having the courage to actually say this isn't working, because I have certainly seen people slog away when things aren't working, and determination and resilience are definitely important here, but so is knowing when something's not right and needs to change.
Absolutely.
Fantastic, Marc. Thank you. So, Marc, forgive me, no discussion with you would be complete without a conversation about that TikTok video. And at this point, the listeners are going to be split quite clearly into two groups. The people that go, yeah, I thought, when were you going to get around to that? Like, come on, we need to hear about this. And the other one's going, what? Just Google it. You'll find it. So how did that come about? What did you plan to be a social media superstar? Did you plan to be the most watched TikTok video the University of Bristol has ever had? I mean, how can one plan for that? How did that come about, and how was it?
Okay, so that is such a exciting but weird journey. So the background for this is, and the short answer is, planned for it? Absolutely no. So the background was 2 years ago. I was covered in Springwatch with my research. And because I was so immensely proud for that coverage, I asked our university press department whether they would do a press release. I said, yeah, let's do this. And they asked me to record like a 1-minute video. At the time, let me start differently, that the BBC have very short turnaround times. So I didn't know whether I was on the show or our research was on the show until 5 days before.
Sure, because they record a lot more than they show. So they record loads of people. Some of them may never make it onto the screen.
Exactly. Yeah. And so on the Friday, I hear about this. I talked to our brilliant media team and got a new contact. The name is Nim Nefwa, and he's now still with us, and he has been a fantastic companion in this journey. So on Sunday, I was at a conference. For the whole week. So he made me record a 1-minute video for his benefit. And then he said, on Monday, can you do it slightly differently and do an anchor at the beginning? So in the lunch break at the conference, I just stood outside and recorded a 1.5 minute thing and sent it off to him. And
one take, no lines, no auto cue.
not scripted. I just explained
just
it.
you and talking with your enthusiasm for your research.
And I provided a lot of materials, and I thought he would use that as a trigger to sort of write his press release and then put some media on there. And I forgot about it. 3 days later, I come back from the conference, and Nim and his team had worked his magic, or their magic, put it on all the different social media channels, and it was trending everywhere. And I came back as social media, I call it maybe phenomenon. You know? At the time, we had racked up a couple 100,000 views, and it kept going. And the highest number we had in the end was TikTok. We had 1.2 million views after less than a month.
Research. Like, research isn't known for being a TikTok phenomenon. Like, it really isn't. It's incredible.
It took us by complete surprise. I think it was just a combination of this very inspiring story and a very unlikely connection between Moth and our personal health and well-being. And it just, I think all the stars aligned to make this happen. It was a fantastic journey. For a couple of weeks, I was a TikTok addict, watching my viewer numbers rise and rise, and that was great. And I think for over a year, this was the most watched research content in the UK ever. I think I might still hold that record, but now the university at least has a non-research content that had more viewers on the university account. But still, this is a remarkable achievement that I'm still not sure I fully deserve, but I enjoyed that so much.
It's an incredible achievement, and it's one to enjoy, I think, and not think of deserve. I agree. It was an amazing story. It's an amazing story, and the link between moths and our health is not an obvious one, and therefore an intriguing one. I also just think, and that's why I asked if you did it in a single take without lines and so on, is there was I watched that video lots of times, there was a wonderful charm of your entire authenticity. It felt like we were just watching you talk. It didn't feel like a presenter. It didn't feel like a sort of public engagement in science. It felt like someone talking about something they were really excited about and wanted to explain to a wider audience. And I think that had enormous charm and authenticity. So that's my view for what it's worth.
Well, thanks for saying that.
And actually something that sometimes researchers worry about, presenting their work in an accessible way. And indeed, it can be really hard. And some people do need to really learn and have training to do that. But there's too much training and too much formalizing of that can actually make it quite wooden and stiff. And having that just let your excitement and your love for your work shine through has a real place. So I think there's a case study in there for training materials.
So I was invited to an early careers event up in Sheffield earlier this year to talk about that experience. And I think what you just said is pretty much summarized my take-home message.
Great.
Talk about something that you're passionate about. Don't overdo it. Make it unpolished, make it authentic. And that, at least I believe, has carried, and the people that know a lot more about social media than I do have told me that this unpolished authenticity actually is what carries that type of video.
Yeah, I think there's a lot of really polished stuff out there. I think people really appreciate that. Just you're seeing the actual human being and not like a product of a committee, if you see what I mean. Amazing. Okay, so coming back to Attacus Acoustics, we've got this really exciting period of building the team, of waiting till exactly the right moment to step out from the umbrella, as you say, and either feel the sun or the rain, or probably both. You know, this is Britain, not just in kind of literal terms, but also in terms of as a spin out. You will feel both, and the thunder and the lightning and the snakes falling from the sky and all the rest of it. But let's sort of turn our eyes away from that moment a little bit, which is exciting and terrifying at the same time. Where would you like Attacus to be in a couple of years? And what would you like it to have achieved in the longer term? What is the ultimate goal that you'd really like to see? What would you like your sort of retirement speech to deliver, or something like that?
So I think my deepest dream is to turn that discovery, that invention, into something that gives back. So having achieved a slight increase in health, making people's lives quieter and healthier. So that's my dream, that we can achieve this somehow. But we can achieve this in many different ways, and Attacus Acoustics is our vehicle for that. We are in deep discussions and have made quite a few changes into what our first market is going to be. So architectural retrofit is an important one. So rooms that are already there, talking about shared offices, noisy rooms in your homes. So you put something up on the wall and that makes it a less noisy and healthier environment. So that, of course, there's lots of solutions out there already, thankfully so. But the technology that they're based on is all fibrous porous absorbers. And they are, let's face it, a mature technology, and they're about 200 years old.
Yeah.
So big transformative inventions are in the making in many different sectors. So we've got competitors out there, but we believe that the Moths have given us an approach that nobody else can do. So what they had to do is they didn't just have to be very thin. Some others can be very thin, some other solutions. But what Moth can do is they are very thin, but they are very thin and cover all the different frequencies that bats might be using. And that's the holy grail. That's the target zone. This is where you want to go. Something that is broadband and ultra thin. And that's what the Moth can do. So we will try and get a first product range out for wall-mounted or ceiling-mounted sound absorbers. In parallel, we are in advanced stages of a co-development agreement with the aerospace sector. So we've got an airplane manufacturer, foreign airplane manufacturer, who is developing quieter cabins on turboprop machines. So that's a very specific development agreement that we're working on. And that these two are what we are progressing on at the most at the moment. There are obvious defense applications as well.
Really, really exciting. And is this something you see emerging from university and you let it go? You let it fly, as it were? Or do you want to keep involved? Are you in too deep to let it go and fledge from you?
So I've been thinking about my role in this for a long time. And I've experienced myself in this journey, and I found things that I like more than others. So there was a point where I could have chosen to be the CEO of this. That would mean stepping out of my role as a professor and taking on, or at least part-time, and taking on a more responsibility, a bigger responsibility in that company. I decided against that because, to me, the professorial role includes interaction with students and being given the opportunity, the brilliant opportunity, the privilege to teach students that want to learn and have the opportunity to inspire them in lectures, in practicals, in tutorials. That is, I still believe, one of the most rewarding parts of what I do. And I am not prepared to give that up. On the other hand, I don't really like negotiating. I'm a cooperator. And if I've got somebody and I need to get some tough negotiations put through, I don't take joy out of this. Others do. So my decision not to take on a big C role in the company, I made about a year and a half ago. So I see myself as creating this as a child, assembling it in the right way, and then letting it go, letting it evolve and letting it develop. Of course, I'm going to be on the board, but I want others to make the decisions and let this child of ours grow.
And it's that theme of, it's a theme of humility. And I mean kind of two things by that as well. You've had that reflection that this is not necessarily, well, not just your skill set, but what you want to do, what the role you want to play. There's a flip side to it. Sometimes the academic, be they an established academic like yourself or a postgraduate or anything in between, sometimes they can make an absolutely brilliant CXO, CEO, CTO, whatever it is. And having the confidence to go, well, I don't quite know, but I'm going to give it a go, can be equally humble, if you like. It's having that self-reflection and being honest with yourself about, do you really want to do this? No, I want to do this thing over here. And by the way, on the students, I couldn't agree more. It's another reason I never left when I found my own company. Working with students is definitely one of my favorite parts of my job. But I do know of examples, I can think of at least half a dozen, of the academic who has taken that step with heart in mouth, with terror, and is now doing amazing work. There's that open-mindedness to which is the right role, and there isn't a single model. And then if I had a penny for every time someone's told me there's only one way that this works, well, I'd have a lot more pennies. Yeah, great. Marc, you've talked with great warmth about the support you've had from various teams within the university and the financial support from some of the devolved funding from government. And you've talked about the Bristol ecosystem and the benefits that's brought you. But I believe you've also benefited from a specific government scheme called ICURE. So I wonder if you could say a little bit about that, what is given to you and your colleagues, and I guess who it's right for. What kind of researchers would benefit from this themselves?
Okay, I'm glad you're bringing this up. So ICURE is a very well-designed, powerful and effective set of training sessions that gets you incorporation ready. So it's multiple stages. Some of them require more commitment than others. And we completed the 2 last stages of this, one of them called Explore, the other Exploit. The one Explore is about finding your fit to market. That takes 3 months and it pays the salary for a lead entrepreneur. And then the second set does the same thing, but this is then developing the framework, setting up the company, coming up with a business plan. We've done all this. So if you go through this process, it's pretty much a one-stop training to get you ready to start your own company. And this has been a tough ride. You have to learn so much, but the team delivering this are so knowledgeable and supportive. The breadth of topics covered, but also the resources given really help you get where you need to go. I can only encourage everybody to consider the ICURE training. It's brilliant. It's also very competitive. So make sure that you talk to your local tech transfer team on how to make a winning bid to the ICURE training. And overall, I think it has been the most important accelerator to all our progress. So yes, more ICURE, please.
I couldn't agree more. I confess I'm an ICURE graduate from 10 years ago when it was really new and quite different, admittedly. What I love about it is, you're right, it's really intense. There's a huge amount to learn. It can be quite sort of dizzying almost when you realize how much there is to learn. But as a founder, you got to learn that stuff. ICURE structures it, makes it accessible, makes sure that you have all those basics and you haven't missed some big category of thing you need to know about and you didn't even really realize. So that structure, also the cohort sense. You talked about being part of a cohort with the Enterprise Fellowship, and I've really found the cohort feeling of ICURE quite important because you're talking with other people at a similar stage of development and understanding to yourself.
Yeah, absolutely. So we were just shy of a dozen projects in that cohort that we went through together. Our team, there were 3, our tech transfer officer, who still is my partner from Dre, myself as the academic lead, and then the entrepreneurial lead. And that person did most of the training, and there was a real sense of community that they were developing. The other 2, us, me included, were only invited to some of the events, but even we contributed to and profited from that whole feeling of community, of joint achievement. So even though in the end you're going to compete for venture capital, that never was felt during that training process. This was really everybody working on the same thing, having the same goal and helping each other out as a cohort.
And that can be so powerful. Marc, I really can't thank you enough for your time and your insights and your warmth and enthusiasm for everything you're doing. I guess my final question, and I can't resist it because you started by telling me about this young PhD student out in Costa Rica working on a project and then sees Moth and can't resist exploring what's going on with this moth and how that's led you and all the many, many other things you've done in parallel while never losing sight of that. I need to properly understand this and then I need to find how this can benefit humankind. If that Marc were to be able to look at this Marc and see everything you've done, including but not limited to the Attacus story, what would he think? What would he say?
I think I wouldn't have had the courage to embark on this journey back in the day. Mm-hmm. And I think that's probably the message here. It's a big project. It has taken me a long time to get there, but every step was just logical and small and achievable. And I think the main driver was not to give up, just to keep doing what you're passionate about. And then there were times when there was no funding and we were working on other stuff, but it resurfaced and it stayed with me. And then you got this gut feeling that there is something to it. And this was an amazing privilege that actually this time it came through, it delivered. And we are sitting here and talking about some exciting inventions that are ahead of us.
So would young Marc be surprised that you'd overcome all those various setbacks where there was no funding, where there wasn't the time, where there wasn't the opportunity? Would he go, yeah, damn right, that's what I'm going to do because that's the kind of person I am?
Okay, that's very hard to teleport myself back in there. I think it's about as far from my ambition at the time than it could be.
Excellent. Excellent. So if you were to turn the tables, if you were to put a little word in young Mark's ear when he's falling asleep dreaming of moths, what encouragement or warning, what would you tell him? What was the advice you'd give that young person?
Well, if you're convinced that it's great, stick to it, even if others are not.
I can think of no words to add to that. Professor Marc Holderied, my colleague and friend, I'm so grateful to you for your time. This has been a fantastic discussion and filled with humour and warmth and insight. Thank you again very much.
Michelle, thank you so much for having me. This was great fun indeed. And yeah, it was a privilege to be here today.